What I want to go over in this one is specifically how to find this information as it applies to your relays. The only reason that you're probably doing this is because you need to figure out how to make this calculation. And yes, all of these do it differently. That makes it awfully confusing. And so I just want to go over how to find this in the manuals, because that is the number one source for the truth on each of these. So in the manual, this first one that we're going to do is the BE147N. That's the relay that we have here in this manual, and you can see they give you a lot of information. I do kind of want to point out every manual has a lot of this application and why, and I mean they're trying to sell their relays, right? And then also protection and how it does it. But in some of these older solid states, you have to realize that they weren't all the same, and some of them were for different systems. And so you need to find your nominal voltages, your rated power supply. You might have to provide power to that relay. It might not be a 120 volt relay. It might be set for a 208 volt relay. So if you and you might test it at 120 volts, thinking that's the nominal, and it's not. So you need to make sure that you're reading your catalogs and testing them accordingly. And I understand that some of this stuff might be hard to read, so use the zoom feature that your computers come with, and use the tools adequately. Go ahead and read and figure out, for example, negative sequence voltage. It tells you right here. It should pick up. Pickup is in increments of 2%, and the accuracy is one plus or minus one unit of the percent setting. Right. So 1 unit is 1% if you were to look at it. And where does that come from? Well, it comes from the front of the relay. This little setting, and we're going to go over this later. Okay, so just try to make ends meet and compare what the manual shows you to what you have in front of you, and try to figure things out. There's a lot of information in here as far as settings and tolerances. We're not going to go into timing on this one, but there is one more thing that I want to show you down here towards the end, which is a lot of these older manuals have test procedures, and so it tells you how to test these relays. And we're going to go into this more later, but I just wanted to kind of show that. So that this manual is not long. It's 36 pages. There's no reason to sit here and not know how to test the relay if you understand how to do the math. Next one is the IQ Data Plus 2. This one is fairly straightforward. In this one, if you were to read closely, this relay operates on voltage unbalance, and I'm trying to scroll to right here where it tells you that. Okay, so it's a voltage unbalance of a certain percentage above or below the nominal, and that's determined by the dip switches. Oh, well, what's a dip switch, Tom? A dual inline package is what dip stands for. Google can tell you that very easy, and what that just means is that there's two rows of pins in which they're mounted. It's just these little switches on the side of the relay, and I'm going to show you those later anyways, just to be clear. But if you're like, Tom, I don't even know what these dip switches are or what they mean, there's just so much here. Okay, well then why don't you read the manual, because when you get to certain pages, you can see, oh look, they tell you what every switch is for. It's almost like the manufacturer wanted you to figure stuff out. So it's all here. It's just a matter of finding it in the book. And for example, like switch 1 right here, it tells you switch number, or slide number 7 on switch 1. There's 8 sliding switches, but the whole thing as a block is called switch 1. And then what does each one do, right? Is the line frequency 50 hertz or 60 hertz? That makes a big difference for timing. Okay, and then the CT ratios, that could be your switch settings. It could also be many other things, action on under voltage, over voltage, and we're going to go over a lot of these later. But I'm telling you, if you can't figure out your relay, it's because you're not reading the manual. I promise you that, or the right manual, because one of these later you're going to find out that we had to go through many different manuals. All right. The next one that we're going to do is the IQ1000. This is a motor protection relay, and we're focusing expressly on the intent of determining how it determines current unbalanced protection, which is this right here. This is all in the manual. Look at this. This is positive sequence and negative sequence, both listed here. And so that's what we have to do calculations on. And they're pretty thorough in their explanation, but they do miss a couple things in this manual. And I'm going to go scroll quite a bit down. And so you can start to see how they do some of these curves. And they try to help you with the math and how to figure out these curves. But we actually had to dive into several more manuals to get the final answer on what is really determining certain values inside of this relay. And it became really challenging. So sometimes you actually have to dive into more than one, maybe 3 or 4 different manuals to find the right answer. And that's what I'm trying to get at here. Another relay is the GE 369 motor management. I like how GE has their stuff set up. GE and SEL both have a pretty good setup in their bookmark tabs, so use them to your advantage. Under installation, you can always go to electrical installation, and it'll tell you what all your terminals are, right? How hard, I mean, you don't have to read the relay on GE. Just this page right here. Just be careful because they do have swappable cards on their GE relays, especially their newer 8 series. And in the UR relays, you can swap out cards and then everything changes. So you need to read the fine details for some of them. And then also read your catalog number because the high or low or whatever determines your power source. And do not, hook up 120 volt AC to a 48 volt relay. That will cause a lot of smoke. Okay. So there's plenty more in here. And then I'm also going to scroll down into, I believe, right here, set points, current elements, and then current unbalance. And this tells you right here how to do the calculation for a current unbalanced equation, right? And there's two different ones depending on whether or not the average current is above FLA or it's below FLA, right? We'll talk more about this later, but I'm telling you, all the tools are here. The next GE manual, it's the same setup. So what I'm going to do with this one instead is I'm going to show you something else that the GE also does in the manuals. Because again, it's still mechanical installation, electrical installation, all the same stuff for the most part. But what GE also has is under introduction, specifications, here are the time delays and the accuracies for example, your CT inputs, right? Or your accuracies for your output relays, how fast they should be. It says operate time 10 milliseconds. That's the maximum, right? And then don't forget that you also have to apply that to the protection. So protection, they've given you the total specification for the protection right here. Pickup accuracy 2% plus or minus, timing accuracy half a second. That's a long time. And I see this all the time that their accuracies on their timing is slow. I don't know why it's caused, but I can tell you that that they already know it and they accommodated the manual for the delay on the relay. Okay. So just be aware of that. And this is why testing really matters because not all tolerances are 5%. Okay. It says or plus or minus 5% of total time. And then read that note 1, right? What's note 1? Let's get down. We got to find the end of it down here somewhere. It's going to show note 1. For timing accuracy specifications, mark note 1. It may increase or decrease depending on whether or not you have the motor load filter interval set. And when the set point is greater than 1 cycle, trip alarm times increase. So it'll basically note 1 means your times could be 1 cycle longer depending on one different setting in the relay. Okay. And usually this is it's going to be half a second, 0.5 seconds, or 5%. And what they don't say here is usually whichever is greater. Okay, so 5% is 50 milliseconds. Well, then it's obviously going to be half a second as your minimum or your maximum. Next one we're going to go into is the 869 relay. Not too much to really talk about in this one because it's all the same stuff for the most part as the other ones. GE's pretty consistent in how they make their manuals. Again, you're going to have installation, and so you're going to have your well, if I can find it in the right here, oh, that's because we're under introduction, installation. Here we go. We've got everything open here and we don't need it. So installation, again, we're going to have physical and terminal connections. Here we go. Scroll to the next pages. I went way too fast. And so you actually have different banks. And this is when reading your catalog number really makes a difference because these modules do change depending on what you have installed. And they also give you a generic setup for how to hook up to the relay. There's a lot of good stuff in these GE relays or in these manuals. So the next thing I want to talk about in here, again, is just under set points, protection, motor elements, current unbalance. And you can see that this one, it's listed right here. Again, this is a different formula than some of the other ones. So don't assume all GE relays are the same. They're not. Last one is the SEL 710. And like I said, with the GE relays, they're pretty good about with their manuals, putting things in order and making it easy. So specifications, you're going to have your individual CT inputs, for metering specs, and then also your output contacts for how fast they're supposed to be. But again, they're going to have protection-based specifications in here. And I do go over these in the last video, but specifically, we're just going to go to current imbalance. Here you go. So I kind of wanted to show it here, and I'm going to get my hand so that way I can move this around. If you look at that, it says current unbalance, phase loss 46, setting range is all of this, accuracy plus or minus 10% of the setting. That's huge. And then timing, pickup and dropout, the timing for the pickup and dropout is 1.5 cycles. So it's going to be slow. And then the accuracy of the time delay is 5% of the setting plus or minus a quarter cycle. I'm telling you that a lot of these current unbalances are sloppy, especially in some of the newer relays. I don't know why. I wonder if it's because they're trying to do an RMS calculation, so there's a delayed calculation in that. But still, don't assume that it's going to be instantaneous and fast. Some of these are slow, and some of their pickup tolerances are sloppy. So read the book and make sure you know how to do it. And also, read the book, and we can go to protection and logic, and then basic motor protection. Oh, not overcurrent. What we need is not undercurrent, current unbalanced elements. And here is the calculation. And you need to, don't assume this is just it. Okay. It says when I average is greater than the motor rated FLA. Okay. So, now here's below FLA. This is the other calculation. And they tell you what I am and I have. We're going to do this calculation later and simplify it for you. So hopefully this helps you understand how to research. If you're really curious and you want to follow a logic diagram, here's a logic diagram as well. Okay. So hopefully this helps, and I'll see you in the next one.